To especially getting ready, thinking about our test on Friday. So we're doing them all today. We're graphing them all today. So your first page of notes, focus, my friends, focus. There's really not a lot for you to fill in, obviously. We're just going to kind of take a look at how changing some of the values changes the center. So of course, I don't really get too crazed about, oh my gosh, what transformation is this? Obviously, if we change x to x minus h, it moves it right. You can read moves left, moves up, moves down. So I really care more about this next picture here. We're used to, and it's written on the board over there, our standard equation of an ellipse. I just picked a nice, easy ellipse. Those are nice to look at. Notice you're going to have the differences today. You're going to have this minus h minus k in there. So that is going to take your center off of 0, 0. Notice, I wish we had color copy machines. The original one's in blue. The shifted one is over here in red. So notice minus h moved it right, minus k moved it up. So anytime you have a value in parentheses today, if that said like x minus 5, it's going to be 5 right. Y minus 7, 7 up. You're always changing the sign when you go to write down your center and do the shift. That's the big, exciting, new, fancy thing of today. So cruising on. Page 1 done. So our center, notice there's a blank on here now for center because it's not just 0, 0, so we feel we should actually write it down. So of course I'm going to change the sign on positive 1 to negative 1. And minus 2 with y goes to a positive 2. So you're going to start with a different center now. Negative 1, 2, got it. Now I mark it out the same way we do all ellipses. 4 is under x. I'm going to square root that, square root of 4, 2. Under x, so left 2, right 2. Left 2, right 2. We'll see how my drawing skills fare today. Okay, 9 under y, square root of 9, 3, so up 3, down 3 from your center. Okay, let's see how my ellipse turns out. Could be better, could be worse. That's how I'm going to look at that one. Now, vertices, remember, just a quick review, it's been a hot minute since we've done some of this, are the endpoints on the longer or the major axis. So these ones in blue, of course, are your vertices. Now, these are easy enough to get on this one. I mean, clearly I can just get the coordinates off the graph grid. Negative 1, so on and so forth. Or, you know, I can't help myself. Eventually, we might have square roots or something. So, So the vertices, the bigger number, of course, under y. So that's why they're the up and down, the vertical ones. So x would stay the same. Of course, square root of 9 is 3. So a quick, easy way to get them is you're adding and subtracting 3 to the y. 2 plus 3, 2 minus 3. Now, I know that's, I forgot the comma, hit the comma there. I know that's dramatic for just getting the points from looking at the graph, and I'm well aware of that. But like I said, eventually, maybe it's like the square root of 5. So I would have to put 2 plus or minus the square root of 5 for exact style answers. I'm just prepping you for that. All right, length of the major axis, how tall is it? 6. We went 3 up, 3 down. Minor axis, how wide is it? 4, 2 left, 2 right. Foci. Now, our foci equation, just it's been a minute, so let's jot it down here. Easy way to remember it, if it's addition in the equation, you use the opposite, it's subtraction. So I'm not going to do 4 minus 9, that'd be a negative. I'm going to do 9 minus 4, or 5, and then I square root it. Now, square root of 5, of course, does not turn out to a nice number. That's okay, that's not a big deal. I just happen to know, because I'm going to mark it on the graph here, I don't know why I know this one, I just do, it's about 2.2. So if I want to mark it actually on my graph, of course, from the center, I'm going to go up 2.2, estimate it, down 2.2. So the red dots are the foci. Now, I need exact coordinates on this. This is what I was prepping you for, okay? So, of course, we went up and down from the center. The x stays the same. But from the center, I went up a square root of 5, and I went down a square root of 5. So there are my exact coordinates, which you're going to have to give the exact coordinates of the foci. Now, I know it doesn't ask on this one, but you know, I can't help myself. It's been a while, okay? And you never know, it could ask a whole lot of stuff on your test coming up Friday. What if, just for fun, I know it doesn't ask, do you remember how to calculate eccentricity?
C over A.
C over A. So square root of 5 over, which is?
3.
Got it. Okay. I know it didn't ask, I just wanted to review it just because it's been a while, that's all. So any questions on the first one? That's our big exciting shifting of an ellipse. Really not that exciting. Okay, let's do an equation of 1. And remember too, when we come to the test, you'll see it. I don't care if you use them or not, but I know this one does tell us to graph it, so obviously I will graph it. But I am going to give you like a sheet of like scratch graph grids. So if you did want to mark out anything when you have to write an equation, because sometimes it's easier visually to see it that way, you will have that. All right, vertices of the ellipse, negative 7, 3. Let's plot them. Negative 7, 3. Got it, 3, 3. Foci, negative 6, 3. Okay, I'm just going to put an F by these, so the green ones, so I know they're the foci, and then 2, 3. Find the equation of the ellipse and sketch the graph. Okay, we got it. Well, first thing we probably need to know, clearly that if I drew an ellipse, it's not centered at the origin. So the new exciting lesson of the day, we need that center. Now, a couple ways to get the center. You could look at that and just try to figure out the middle dot between the foci or the middle dot between the vertices. Or, just because the love of math overwhelms me, you could use midpoint formula from geometry.
Just count it out.
No, but if I give you decimals, something crazy, you never know. You never know. We could do midpoint formula. Remember, you add the x's, negative 7. I'm writing it out. I know you can do this in your head. And you average it over 2. Or, of course, add the y's over 2. You are more than welcome to count it out. I do not care. You're going to end up with the negative 2, comma 3. Okay. Just however you want to get that, clearly you could get it just off the picture. Now, let's set up our equation here. We know it's adding because ellipse. Hold on. Now, ellipses, remember, the order is just always alphabetical x, y. But I'm not just going to put x squared, y squared like we have in the past for the numerators. We have to account for our new center. So our x squared is the center, negative 2, so I'm going to x plus 2, and then y minus 3. So of course the next question or the next thing we need to work on, A, B, all of that good stuff. So let's mark our center on here, negative 2, 3. I'm just going to put a C for center. Now, they told you the vertices, so I can very easily get you A. I'm just going to count it. Remember, A is the distance from the center to the vertices. 5. So I'm like, that's 5 units, 5 squared, 25. Piece of cake. The tricky part on this one, I don't know B. I don't know how tall I would count out my ellipse when I draw it. So I'm like, okay. What else do I know? Clearly they gave us the foci for a reason. So I can count from the center to the foci. 1, 2, 3, 4 points, 4 units. So my C is 4, and we knew A was 5. So just jotting down what we got. So I'm going to use my C squared equation. And remember, it's plus in your equation, easy way to remember, minus on the foci then. So C squared 16, A squared 25. I'm going to keep solving. I'm going to subtract 25 off 16 minus 25, of course, negative 9. Don't let the negative scare you, because you have a negative on your B squared. So in our heads, B squared's 9. So it's kind of like a little puzzle to fill in all the pieces. Now they do want me to sketch it. I am going to sketch it. I'm just going to erase some of this counting stuff off of here because I kind of made a mess on my graph grid here. So let's erase this 4 and whatnot. Okay, so 5, we already had the vertices on there. I kind of erased that guy. But now I know I'm going to go up 3, down 3 from the center. And I'm going to, of course, get my ellipse equation drawn there. And like I said, I am going to provide you with some like scratch graph grids on your test. This one did ask you to draw too, but just if you like a visual, you don't have to use them. I am going to give you some though, just for the love of math. All right, so that was ellipses. I mean, that's really not any more exciting than that. Let's get into parabolas. So again, you've got the equations over there, the green ones. You can see now the vertex is just not at the origin. We're moving left and right. Parabolas to me are kind of the trickiest of all the figures because the equations kind of work backwards. Like the ones that start with x, you would think would open sideways, but they actually open vertically. The equations that start with y, the y squared, those of course, you would think would open vertically, but they open horizontally. And clearly P is positive to the right, P negative to the left. So let's review, get into a parabola, just because it's been a minute. So here we go. So this time, notice you do have a blank for the vertex. In the past, they were all 0, 0, so what was the point of writing that down? You just have to be, as always, conscientious of order and signs. But, I mean, common sense. I want to X, Y, and we know anything in parentheses, we change the sign on. So X, I'm going to make it positive 3. Y, I'm going to make it positive 1. That's the first thing I'm going to mark. 3, 1 over here. Good. Crushing it. Now, doesn't ask, you know, I just like to know which direction it's going to open when I'm getting into this guy. So again, y minus 1, you would think vertical, but it's opposite. It's going to be left or right. And since that 4 is positive, it's going to open right. Now, I'm going to use the length of the lattice rectum. So I'm going to say that, or the focal diameter, to draw this. So I am going to write down what 4p is. So remember 4p equals that coefficient right there, 4. And of course, p is 1. So that helps me get my focus and directrix, if I can say it here, all in one shot. So from the lovely new vertex nut at the origin. So it opens right, your focus should be to the right of it. So I'm going to go 1 unit to the right. So that guy, I'm going to write its ordered pair right now, you're at 4, 1. Let's put the focus, 4, 1. All right, directrix. Erasing, this darn eraser's too big on here. 4, 1. Okay, directrix, 1 unit the opposite side. Now, because my parabola is going to open right, your directrix will be that vertical line that it opens away from. And then I'm just going to write down that equation, that blue dashed line, x equals 2. Yeah, I erased my red pretty here too. Now, nice, easy way to actually draw your parabola. From your focus point, which is my green one, the length of the lattice rectum, it doesn't ask for us, remember, is what 4p is. I'm going to put L over for lattice rectum. So I need it 4 total wide. So I'm going to go 2 up and 2 down from the focus, and then I can draw that parabola. Got it. So just a good review of parabolas. It's been a while since we've done those. And again, to me, these are the trickiest, just because it's kind of scrambled in your mind. All right, ready for the next one? Next one's a good one. I'm like, whoa, what's happening here? We are nowhere close to being in standard form of a parabola. I need like parentheses squared on the left-hand side. Okay, okay, okay. I like to get your x squared over here. So I want to make that a perfect square trinomial, so I can factor it. So I'm going to complete the square. Remember how to complete the square? Oh, God, I love the responses. You're going to do half of b, and then I'm going to square it. Remember, b is your coefficient on x. Half of 4, 2 squared, 4. So I'm going to add 4 over there. And of course, I'm going to add 4 on the other side too. So now it's getting fun for us, sarcasm, because we have to complete the square to try to get it into the form. All right, reason of the red 4 is the left side factors. Multiply to 4, add to -4, -2, -2. I'm going to put it quantity squared. Right hand side, I'm going to add 8y. I'm going to add the -28 and the 4. So we'll have -24. Now I'm going to do one more thing, and I should have left myself one little more teeny tiny piece of work here, line to do this on. Remember your standard form, we want that 4p in front, we want that coefficient so you can figure out what p is and the length of the lattice rectum. So I'm going to factor the right. I can pull an 8 out on the right. So let's do that. So 8y minus 3. Should have left a little more room. So now I have it in the form. I can do it just like the last one, get you all the info. Okay, vertex, and I'm going to sneak it in here. Now remember, x comma y, anything in parentheses you switch signs on. So -2 is with x, I'm going to switch it to a 2. -3 with y, switch to a 3. Why did I put this graph grid up here so high? Okay, let's move it down so I can reach it. 2, 3. Short people problems. Now, x squared, you would think it's horizontal, but it's vertical. And because our 8 is positive, I do know it opens up. And of course, I'm going to get the 4p, I'm going to get the lattice rectum, all the good stuff. 4p equals, we needed that 8, that coefficient. So I know p is 2. Okay, so from my vertex, since it opens up, I'm going to go up to, there's the focus. Let's write that guy down. I'm at 2, 5. And then the directrix, I'm going to go to the opposite direction. And since it opens away from it, it's a horizontal line. The equation, that red dashed horizontal line, y equals 1. Okay, 4p is our lattice rectum length there of 8. So through the focus, I'm going to make it 4 right, 4 lefts for a total of 8. 3, 4. Got it. There we go. That's not too bad of a graph. Now, don't forget if you're ever like, oh, which way does it open? What's happening? You have that Conic app in your calculator. You can punch it in to double check it if you really get in a pinch. But, but you're going to have to type in this blue form here where we completed the square on it. Because remember, in your Conics, in your calculator, it asks you for like H, K, and then it will ask you for like P. You can't type in that original equation. Your calculator won't do it that style. So I don't know how helpful the calculator is. Okay. All right, so we did ellipses, parabolas, let's do hyperbolas. So you can see these are really similar to ellipses and how you count them out, remember? Notice your equation, remember, goes to minus. And which letter comes first here does matter. If it's x, it opens horizontal. Y, I would, of course, rearrange that so the minus is in the middle. That irritates me. Y, of course, up and down. And our center's not at 0, 0 anymore, but same deal. You're going to switch the sign on anything in parentheses with x and with y. Okay. Counting them out the same. So here we go. A shifted conic has that equation. Well, that's pretty nice. Complete the square. In x and y. Fun. Super, super fun. To put the equation in standard form. Okay. Well, let's do it. We have to complete the square twice, once on x, once on y. So first thing I'm going to do, I mean, it's in a good order. I like that these x squareds are together in the front. Like if that 72x wasn't next to it, I would make it be next to it. I'm going to leave some room to, of course, complete my square on that. My minus 16y squared. I'm going to leave some room to complete the square. Okay. Now, to complete the square, remember your lead coefficient has to be a 1. So I'm looking at the x's. I got to pull the 9 out first. 9 times 8 is 72. Now I'm going to put my blank in there. Okay, half of 8, 4 squared. But, let me put my equals 16 over here, and I'm going to kind of shove it over a little bit, because I think I'm just going to need some room. I am not just putting plus 16 over there. I'm going to do a little bit of math. You really did. You have that distributor. You really have 9 times 16, which, what's 9 times 16? I got to look. 144. I did it earlier. So be conscientious of your distributor. Now, for y, I need a lead coefficient of 1 on the y squared, so I'm going to factor, careful in the signs here, negative 16 out. So that makes this plus 2y. Negative times a positive a negative. Put my blank. Half of 2, 1 squared. But I'm not just going to slap plus 1 over here. I really put what number on the left? I really put a negative 16. You have that distributor. Ooh, okay, all right. Lots of fun work. Lots of good fun work here. Okay, purpose of this, we can factor this, multiply to 16, add to negative 8. We got it, negative 4, negative 4. I'm going to factor the blue y's, multiply to 1, add to 2. Switching colors here, 1 and 1. And I'm going to add up all that stuff over there on the right-hand side. Well, that's easy enough to add. So I'm almost ready, and I didn't leave myself enough room again for my standard form. I'm just going to set it to 1. So I'm going to divide everything by 144. Okay, I'm going to sneak it under here. So 9, I'm going to reduce it. 9 does go into 144. How many times? 16, I heard it. And then 16 goes into 144 9 times. And then 1. Ooh, that was fun. That was so fun. So very fun. Not hard, but very time consuming for sure. Okay. All right, let's get ready to draw. So center, of course, we're going to change our signs here. So positive 4, negative 1. Let's plot it. Move this out of the way. Positive 4, negative 1. Okay, 16 under 4. So I'm going to square root 16. 4 right, 4 left. From your new center here. 4. 9 under y. Square root of 9, 3. Up 3, down 3 from your new center. Now, hyperbola. Remember, we draw the central box. So I can draw the asymptotes. So I can draw like a double parabola thing. Okay, so here's my box. The central box. And then I'm going to draw the asymptotes. I just draw those from the center to each corner. I'm trying to draw them straight, but we all know my artistic skills here. And then my actual hyperbola, since our variable in our equation, x comes first, it's horizontal, so it's going to open left and right. So I'm going to take this right point I had on the box here, close to my asymptotes, and we take the left point I had, same thing. Whew. And now we have to answer all the stuff. Now, opens horizontal. So from, of course, our center, I went right 4, left 4. So if you have kind of a lot of stuff on your graph and it's hard to see it, and it's like, oh, if I went right 4, that's going to be an 8, negative 1. And if I went left 4, subtract 4, I'm at 0, negative 1. Foci, we need our c² equation. Now remember, it's minus in your standard form equation, so plus in the foci. So 16 plus 9. Well, that's kind of nice. So it's 16 plus 9. 25, square root of 25. Nice whole number like that. Okay, so from the center, I'm going to mark them because why not? I'm going to go 5 right, 5 left. So here we go, 5 right. Just one past that. 5 left. So my ordered pair on those, of course, and again, I got a lot of dots and stuff going on over there in the graph. Well, remember, we went from our center, 5 right, so if I add 5 to 4, 5 left, if I subtract 5 off of 4, and now we must do the asymptote equation. Okay, now, asymptote equations are a little more involved on the shifted conics than they are on just the standard center 0, 0. Here's why. Here's why. I know you can do the slope, rise over run, or 3 over 4, rise over run. But my y-intercepts on them is not just at 0, 0, okay? So I'm going to use point, slope, form. And they go through the center. Both asymptotes go through the center. So I'm going to do y minus negative 1. Now my slope is up 3 over 4, rise over run, so 3 over plus or minus, because there's 2 of them. X minus 4 on the center. This irritates me, I'm going to make it a plus. So we have 2 equations. I'm going to scroll this up just so I don't end up way at the bottom. So I'm going to have y plus 1, that's very sloppy. Okay, so first I'm going to take the positive 3/4 x through. So I'm going to have positive 3/4 x. And then positive 3/4 times negative 4. Yes, I know I have to subtract one. I'm going to do it in a second. We can do that part in our head. To get the second one, negative 3/4 for the slope. Negative, negative, positive. And I'm just going to mentally subtract the ones off the back and list them over here. So I'm going to have minus 4 for the intercept on that guy. And this one I'm going to minus 1, so that will put you down to 2. That's all the math skills in one problem. Isn't that great? So good. Now here's the thing too. Pro tip, always a pro tip. That was kind of old school and a lot of work. You might have, depending on how accurate and how good you draw your graph. I mean, I'm looking at this asymptote line, the negative. I mean, I can kind of see it hits the y-axis right there at 2. It hits at 2. Can you see that? This one I can see, it's hitting there at -4. So if you draw nice and accurate, you can probably save yourself that work and just do your mx plus b from the graph grid. But I have so many colors and stuff here. It is what it is. All right, wasn't that fun?